Okay, so today we are talking about rotations. So our objective is I can identify and describe rotations. Okay, so we need to kind of review what a rotation is. So a rotation is a turn. That was the non-mathematical term. Okay, it's a rigid transformation. Okay, and if you remember, a rigid transformation preserves size and shape. So it's a rigid transformation in which a figure is rotated about a point. Okay? And for the purposes of us, we are always going to be rotating around the origin. Okay, so for what we're going to be doing, we're going to be rotating around the origin. Okay? Okay, the center of rotation is the point a figure is rotated around. Okay? And then the angle of rotation is the number of degrees a figure rotates. Okay, so if you remember yesterday in our activity that we did, we found out the rules for different kinds of rotations. Okay, so if we rotate a figure 90 degrees clockwise, okay, so remember clockwise is like, it's like we're going to the right, okay, clockwise, okay, that's the same as rotating 270 degrees counterclockwise, okay? So when we have an XY, any coordinate, and we rotate it 90 degrees clockwise, the Y becomes the X, and the opposite of X becomes the Y, okay? Okay, when we rotate 90 degrees counterclockwise, which is the same as 270 degrees clockwise. Okay, if I start with that XY point, they switch spots again, but now I'm taking the opposite of Y, and the X becomes the Y. Okay. And then when I do 180 degrees clockwise, that's actually the same as 180 degrees counterclockwise. Okay, so I start with XY, and that maps to the opposite of X and the opposite of Y. Okay, they don't switch spots, they just become the opposites. Okay, so example number 1 says you must rotate the puzzle piece 270 degrees clockwise about the point P to fit it into a puzzle. Which piece fits in the puzzle as shown? So I'm going to rotate 270 degrees clockwise. And remember, that's like 3 turns. Okay, if this is a 90-degree turn, that would be, I'd need 3 of those. So I'm going to rotate this, and then I'm going to draw what it looks like after I rotated it. Okay, so when I'm going counterclock, oh no, so it's clockwise, so I'm going to go to the right. Okay, so 1 turn, so that's 90, 2 turns, that's 180, 3 turns, that's 270. So now I'm going to draw what this looks like. Okay, so it has the one up on the top, the one on the side, then it goes like this, and then it's like that. I know it's not pretty, it's not the best picture I've ever drawn, probably not going to be the worst, but that's okay. Okay, so that is what it looks like. Okay, that's the picture I'm looking for. So I'm going to rotate my paper back, and now I'm going to figure out which one of these looks like that. Okay, well, not A, not B, it's definitely C. Okay, so C is the one that if this is rotated 270 degrees about this point, okay, that it would look like that. Okay? Okay, go ahead and do you try number 1. It's got your quick checkpoints there for you. Okay, example number 2. The vertices of a trapezoid are those. Rotate the trapezoid 180 degrees about the origin. What are the coordinates of the image? Okay, so I know usually I would give you a graph, but I want you guys to get in the habit of using those rules because you could easily plot this and then you're still going to have to use the rules, okay? So when I rotate 180 degrees, okay, I just take the opposite of the x and y values, okay? So I'm going to write that rule. So I have x, y, and that maps to negative x, negative y. Opposite of x, opposite of y, okay? So w prime, the opposite of negative 4 is 4, and the opposite of 2 is negative 2. Okay, x prime is opposite of negative 3 is 3. Opposite of 4 is negative 4. So I'm just taking the opposite of all of those coordinates. And 1, negative 2. So I just took the opposite of all of those. Okay? Oops, z prime. Okay? Example number 3 says the vertices of a triangle are those. Rotate 90 degrees counterclockwise. So 90 degrees counterclockwise, negative yx. Okay, so I need negative yx, opposite of yx. Okay, so j prime, so the opposite of y is negative 2, and then I have my x value. Okay, the opposite of 2 is still negative 2, and then I keep the x value the same. Well, it becomes the y value. And then L prime is the opposite of negative 3 is 3, and then the 1 stays the same. Okay? Okay, go ahead and do the U try. I gave you a graph just in case you want to use it. You don't have to, but I gave it to you just in case you want to. Okay? Okay, so for example number 4, it says the vertices of a rectangle are negative 3, negative 3, 1, negative 3, 1, negative 5, and negative 3, negative 5. So I'm going to go ahead and plot those points. So negative 3, negative 3, 1, negative 3, 1, negative 5, and negative 3, negative 5. So there's my rectangle. Okay. Now, in order to rotate this, I'm going to need to use my rule to help me, and I'm going to actually write real quick, A, B, C, D. I'm going to need to use my rule. So 90 degrees clockwise is y negative x, okay? So I need to change all my points, so this is 90 degrees clockwise, okay, y negative x. Okay, so right now A is at negative 3, negative 3. So A prime is going to be at negative 3, and then the opposite of negative 3 is 3. So that's where A prime is going to be. So negative 3, 3. Okay. And then B prime is going to go from 1, negative 3 to my y is going to stay the same, and I'm going to take the opposite of my x, which is negative, would be negative 1. Okay, so negative 3, negative 1, that's going to be my B prime. And then C prime is going from 1, negative 5. I'm going to keep the negative 5 the same and change that to the opposite of x, which is negative 1. So negative 5, negative 1. And then I hope we can see where D prime is going to be, but let's just look at this. Okay, so my y stays the same, and my x becomes the opposite, which is would be negative 5, 3. Okay, so there's my D prime. Okay, so that's just the 90-degree rotation. Okay, so now I have to reflect over the y-axis. Okay, well we can do that a lot easier without necessarily having to look at the rule. But say you didn't want to have to graph it. Okay, say you just wanted to use the points, okay? If it's just asking you for a point, you can just do this. Okay, so over the y-axis, okay, when I'm doing over the y-axis, I take the opposite of x, but keep the y. Okay, that's from your foldable. Okay, so opposite of x here is 3, and so I'm going to keep the y. Okay, opposite of x is 3, keep the y. Opposite of this x is 5, keep the -1, and then opposite again of -5 is 5, keep the 3. Okay, so now I'm at 3, 3, 3, -1, this is a prime, and then this is b prime, and then c prime is at 5, -1, and d prime is at 5, 3. Okay, you could have done that without putting the points, but if it's just asking you for a point, just use your rule, okay? So the coordinates of the image are these right here. Okay, those are the coordinates of this image. This is the image that they were looking for after it's been rotated and then reflected. Okay? Okay, go ahead and do the U try. It's worth 1 point on your quick check. Okay, example number 5. The red figure, which is this bottom left, so this is your starting point, is congruent to the blue figure. Okay? Describe a sequence of transformations in which the blue figure is the image of the red figure. Okay, so this is going to be my blue, so I'm going from this to this. Okay, so one thing I can think about is I need to get this figure to be like this. Okay, which means I need it to go from the top down like this. Okay, so what I'm going to do is I'm going to rotate my paper until I'm going to draw on a Post-it. It needs to look like this. It's not going to be perfect, obviously. Okay, but I'm going to rotate my paper because then I can just, once I've got it looking like that, then I can just slide it around. Okay, so I need it to look like that. So I'm going to move clockwise. So I'm just going to go one move clockwise. Okay, does that look like that? Yeah, it does. Okay, so if I rotate this, I went just 90 degrees clockwise. Okay, I just went 90 degrees clockwise. Okay, I got it to be that shape. Okay, and then, so I'm going to go ahead and do that. So this is at 0. This one's going to be here. Okay, so if I label these A, B, C, D, remember 90 degrees clockwise, if you look back at your notes, okay, 90 degrees clockwise is y negative x. Now these ones are hard. I know these are hard, but if you remember everything I've taught you, you can do this. Okay, so if I rotate this 90 degrees clockwise, A is going to stay in the same spot. Okay, because it's right now, A is at 0, 0. Okay, well, if I move the 0 to that spot, that stays 0. Well, and the opposite of 0, that's just 0. Okay, so that's where A is going to be. And then B right now is at -1, -4. Okay, so B starting at -1, -4. Okay, and it's going to move to, if I do this, okay, the y becomes the x. So I have -4. And then the opposite of x is 1. Okay, so B is going to be here. B prime is going to be there. Okay, and then C is at -3, -4. Okay, and it's going to go to, okay, my y is going to move into the x spot. And I'm taking the opposite of x, which is 3. Okay, so -4, 3. Oops, I plotted the B at the wrong spot. -4, 1. Sorry about that. Okay, so here's my C prime. Okay, and then my D started at -2, 0. Okay, and so it's going to plot to 0, And then the opposite of negative 2 is 2. So here's where D prime is going to be. Okay, so here's my new figure. Oops. Okay, so far I've rotated 90 degrees clockwise. Okay, now we need to get this to here, this to here, this to here, this to here. Okay, so now I just need to translate. Okay, so I'm going to go 1, 2, 3, 4 to the right and 1 up. Okay, let's see if that works for all of them. 1, 2, 3, 4 to the right, 1 up. That one works. 1, 2, 3, 4 to the right, 1 up. Yep. 1, 2, 3, 4 to the right, 1 up. Yep. So rotate 90 degrees clockwise and then translate 4 units. I'm just going to use U because I'm running out of room. 4 units right and 1 unit up. Okay, so there is your sequence of transformations. Okay. Okay, so in your you try, you're going to describe a different sequence of transformations. So you need to use a different rotation. Okay, I'm going to tell you it's going to be a rotation followed by a translation. Okay. So see if you can move it, rotate it the opposite direction, okay, and still get it into that same spot, okay? Okay, one thing I forgot to have you do is to record on your foldable, okay? So I'm flipping into the rotations rules, okay? And 90 degrees clockwise, remember it takes X, Y, okay, and maps it. I'm just looking off my notes, okay? And maps it to Y negative X. Okay, that's for 90 degrees clockwise. And remember, that's also the same as 270 degrees counterclockwise. So I'm going to write that right here. I'm going to draw a little arrow. That's 270 degrees counterclockwise. Okay. And then 90 degrees counterclockwise. Remember, they still switch spots. Okay, but now the Y is what becomes the opposite. So that's the opposite of YX. Sorry for all the movement. Okay, and then that's the same as 270 degrees clockwise. That's the same as 270 degrees clockwise. Okay, and then remember for 180, remember 180 clockwise and counterclockwise is the same. Okay, so I just take my XY, and when I change it, those just become the opposites. They don't change spots like the other ones. Okay.